Like you said, my name is Abdelrahman Elkhatib. I am a 3D specialist in Tallinn Strategy Center. And I'm coming originally from Egypt, and I'm enjoying working with 3D stuff. Basically, in my daily job, I deal with everything that is connected to 3D data and visualization that we have in Tallinn servers. Our presentation today, the title for it is 3D applications in Tallinn digital twin. Like everybody knows, digital twin or like city digital twin is something that most of cities in newer world are looking for to achieve, and we'll be talking about 5 points mainly. First thing, what is the city digital twin? What is the meaning of it from a 3D perspective? And then we'll be talking about an example project that the Tallinn government is participating in, and it is related still to the smart cities concept, which is green twins. And then we'll talk about the 3D data types that we have in Tallinn government servers, like what type of data, of 3D data do we have, and how we kind of create them and how we save them. And then we'll be talking about benefits and examples of using 3D data in city planning. And then finally, we'll be talking about a few challenges and like what is hard while implementing 3D data in a digital twin model of a city. So basically, the 3D digital twin city is a perspective. It's basically a virtual replica of a city. Like you see here, it's written that it's just created to visualize and capture data, like physical and spatial data, and other types of data in the city, including buildings, infrastructure, and natural environment. And basically the purpose or the main reason why people do this, because it allows users and stakeholders to interact with this kind of virtual city in real time, to test the scenarios and simulate change, maybe emergency situations or decision making or whatever. So and then here, for example, if you just Google a city digital twin, one of the main results that will show to you is Singapore digital twin. They have one of the most successful examples. And here I collected 3 small screenshots just explaining examples of how their digital twin looks like and what is it used for. For example, like you see here, they use it for sustainable transportation, and it's kind of integrating with the autonomous vehicles and the cars, whatever vehicle is driving around the city. And this is something we can relate to it in Tallinn, because we started years earlier, we started seeing some autonomous vehicles running around, whether it's the test buses that were going around done by Taltic, and maybe the new robots that are doing the delivery for us and so on. One of the other example of that Singapore do have at the moment is their in their digital twin is that they can manage, for example, the emergency situations that happen if there's a big problem happening in the city. For example, here, this is an example of how they can visualize and locate the gas leaking problem. So this is very helpful, I assume, for people, for decision makers especially, to decide whether the ways to solve a problem or to define how it happened and how we can avoid it and so on. And then there is another example which is related to solar panel and energy production, which is again, we can relate it to our everyday life in Tallinn with the energy prices changing and the other stuff. So everyone started looking forward to using clean energy and sustainable energy, like solar panels, for example. And this is an example of how they can collect a very as much as detailed data of the amount of energy they can generate from one building or whatever. So yeah. And then in here, this is a quick video where I am showing our 3D model in Tallinn. That basically we do have a full 3D model of the whole city. And this is our kind of first step towards achieving a digital twin concept in Tallinn. And yeah, I am just going to show like what level did we reach so far and how it looks. Supposedly it had music, but for some technical reasons with Zoom, music is not going to work, I think. So yeah, please don't be bored. It's just 3 minutes. Yep. Thank you for watching and for your patience. So then we come to next slide. I just have it in a full screen, which is talking about Green Twins project, which I spoke about earlier, where basically it is a project that's funded by European Union, and it's a collaborative planning supporting system, and it's meant to have a model of urban green infrastructure, and it is a cooperation between Helsinki and Tallinn, which is the twin, basically, cities. And in this project, we have three main sort of sections. First thing is the database of a digital plant library. We'll talk about it in details. And then second thing, we have a digital tool, which is a virtual green planner tool. And then we have physical space, Avalin, or it's like a sort of a hub where people can experience different, for example, the tool, and see also examples of the digital library that we have. So if we talk about the digital plant library, basically we store information of trees and grassy areas, and we make also a projection of growth and seasonal change to those trees. How's that possible? Basically, we do have a texture photography and image processing. So on your left hand here, those are real live photos taken from a different tree species. While on the right hand here, this is a 3D modeled. This is 3D model that I modeled it myself of an example of a tree, and in this case, it's called the species called linden tree. We try to make it as detailed as possible, and on the other hand, we also try to maintain basically the weight, or like how big is the file for each species, because we use it in other applications and it has to be light size. Here, this is an example of the plant growth process, how it is done. Basically, we have an algorithm that we run it over the 3D model that we have. So basically, we create one example of a leaf and branch and the twig, for example, and then this algorithm, once you run it, it starts showing you the same tree in different phases and in different age frame. So, for example, the algorithm try the best of course, by the help of experts and scientists to simulate and visualize how this tree would look like when it's just sort of a newborn tree, or like a new tree, and then how it looks after, I don't know, 100 years. And then we do have the virtual green planner tool, which is basically done to enable users to create and share different urban plans, and also to view and discuss those changes, and how, for example, would the street look like if it has this building, or if we remove this building from here. And same goes for vegetation as well. And this is, again, a quick video showing how it looks like. This is basically the tool that we created, and it is done in a small pilot area in Tallinn, which is just around the old town, as you can see. And it has different modes. You can basically have the person walking mode, where you can see how the city looks like if you're just a normal person walking. And as well, it has the top view, where you can see the whole the whole scene, how it looks like. So yeah, I'm gonna leave you just to watch how it looks like. So basically, this is the main idea, is that we try to create a tool that helps people to imagine how would an area look like in case of more vegetation, or in case of more buildings. And this is the core point of, this is one of the core points of digital twin, I would say, is to simulate and visualize this to users. just for them to imagine how life would look like if we had an extra building, an extra tree. And it's very helpful, I would say, when it comes to decision making and stuff like that. Yep. And then we come to the third part of the Green Twins project, which is the city planning hub. Basically, it is a physical space where you can use advanced technology, and it's done to serve public discussions and decision making on urban planning and development. Like you see in the photos here, we did have a couple of excursions where we could test those tools through computers and VR glasses. And yeah, that's how we imagine it to look like in the future. And it should be, like I said, equipped with art visualization technology and digitally aided mostly. And then the next point we're going to talk about is types of 3D data that we have in Tallinn, which based on those data you have, we could create the examples that you saw earlier, whether it's the Green Twins project, which was created by the help of our assets here or our 3D data, as well as our Tallinn 3D model. So first type we would talk about is the manual high detail 3D models. We call it here LOD0, and they are created manually by whatever 3D application, and the model include as much details as possible, and as well as it has to have this sort of semantic data behind it, like dimensions, materials, what is the building used for, and so on. The next type of 3D data we do have is point clouds, and 3D point clouds, for those who don't know, are a set of data points that are saved in three-dimensional coordinates, and they are basically created to represent a spatial location and attribute. And like you see, that's how it looks. For example, this is sort of a small forest or something. And it is very useful in many cases when it comes to digitalizing the view of the city or visualizing it. And then comes our third type of 3D data, which is created automatically, and it's done by the help of ArcGIS. And like you see, it's just to represent the building or structure, and it has a lower level of details, and it tries to, or it tends to include the basic shape of the location of a building, but not in a full detailed version, of course, as well as, again, semantic data. It has walls, roofs, whatever other data of the materials of the building, and whatever semantic data we do have in Tallinn, it's saved to those buildings. And then fourth type of 3D data, which is 3D scanned models, and those are created by capturing and processing 3D data points using various sensors, like LiDAR, for example, or stereo cameras, or structured light sensors. And those are, I would say, they're very high, they're very accurate. Like you can see, it almost feel real. And it is, again, it's one of the data that we use it to visualize some of our projects. And this is the fourth type. And then comes the fifth one, which is the BIM models. And BIM models are, again, they are modeled manually, but they contain more detailed information about the physical and functional characteristics of a building, and even if it's a small structure. And it's basically, we use it to facilitate design, construction, and management of the building and infrastructure projects. And now we talk about just example applications and like what are the benefits of using, if we talk about using city digital twin, what are the benefits of using this? Just quickly, I'll go through them. We talk about real-time monitoring of urban activities, like you saw, traffic flow management and predictions, of course, virtual tours, planning and development simulations, emergency management. We saw an example of it as well, and environment impact assessments. And here are again 3 examples. The improved visualization, we spoke about it, and how it helps. Basically, it helps to have more enhanced decision making and problem solving. And of course, it increases the efficiency and cost, and like it saves a lot of cost. Now, quickly talking about our future plan, we are planning to have more, like bigger expansion of our 3D data coverage. Here talking about the higher detailed models. Of course, collaborative initiatives with the public and private sector and stakeholders. And we want to create the best possible model concept of Tallinn digital twin. And now talking about the challenges and limitations of 3D applications in Tallinn digital twin. Of course, they are a lot, but here I spoke about a couple of examples. Privacy, of course, the data accuracy. It's always connected to privacy because it concerns the inaccurate data, and this can lead to, of course, the predictions might not be the most accurate ones. And the privacy here arises because we need to collect, of course, more data to integrate it in our projects. And sometimes this data contains sensitive information. So this is one of the challenges. And then other one is technical challenge. Here we talk about limitation of using the 3D applications. Sometimes it's related to the processing of power. As I explained earlier, when it comes to creating trees, for example, you need to maintain the 3D model in a very small size so that the whole application will run smoothly. And of course, this might affect the rendering time, and therefore it will affect the real-time simulation. And was it, and I hope I wasn't too late. Okay, I'm 3 minutes over the time. I'm sorry, guys, but thank you. And if anybody has questions, please let me know.
Thank you. Thank you.
Sure.
I think we are behind of schedule, so at the moment, thank you very much, and hopefully you can join to our conference next year.
Yep. Sure. Thank you very much for hosting me, guys.